Welcome to a lesson with Dr. Powell. Let's talk about Descartes' Rule of Signs. This has to deal with how many zeros there might be of a polynomial that are positive or negative. Let's deal with the positive case right here. So if we have a polynomial, let's just kind of think about a particular scenario. Suppose we have something like x to the 6th minus x to the 5th. X to the 6th grows faster than x to the 5th, at least on a certain interval, or eventually it grows faster, but actually at first, this guy grows faster than that one. So as you go down the powers, what you have is you're going to have a crossing, a potential crossing, if there's a change in sign. Because if one's going faster at first but the other one overtakes it, every time that you have a difference here, you have a potential of a takeover. So as we draw this, starting at least from the positive side going this way, with positive, not with, then when I see one change of sign from positive to negative in these two terms, then I'll think, there might be a crossover between these two, one becoming bigger than the other, one pulling it down to be negative versus positive, and we might have something like this. We might have a crossing, and that's a possibility. Now, if I add in more, such as plus x to the 3rd even, that's a lower power there. So I have one change, then another change. I have another potential conflict, which means maybe somewhere along the line, there was some kind of other conflict. So every time I do this, there's a conflict between the terms because there's a takeover happening, if you will, as you go along this way. So there might be another place where it takes over. And so you get these various different options of things that could potentially be happening as we go along, at least at the positive zeros or positive solutions if you set this equal to 0, or x-intercepts, positive x-intercepts. So now, okay, so in this particular case, I see 1, 2 sign changes, and in fact, maybe I could put another one down. What if we subtracted x squared from that even? Then maybe perhaps there could even be another sign change. Now, this is not exactly the way the graph would look, but just in general, just the idea of having plus minus tells us that maybe there could be, with a 1, 2, 3 different sign changes from coefficients, positive, negative, that there might be 3 potential zeros. Of course, maybe one of these conflicts doesn't really work out, or is not enough to really affect to make a 0. Then what would happen? Well, the situation is like this. Well, that means that the graph is in one part is shifted up or down. So if you do that, the possibility is that maybe potentially, as you shift things around, you're pulling up that hump, and maybe it pulls up enough. There's enough of a shift or different constants being multiplied in that particular part that's not as great as others, or where the whole hump could actually have moved upward, which would mean you would have eliminated potentially two zeros. In fact, it is even possible that this hump right here could have at one point turned into a 0 right here. Now, this guy would have to have an even multiplicity, that 0, because it bounces, which means that eventually if it pulls up enough, and pulling up just happens because of changing coefficients and how the conflicts are occurring, or if they're not, or whatever, if they're enough to make a complete turnaround, it may lift up all the way. And so really, we've decreased the possibilities by an even amount. Now, using this basic idea, we can say this, that the number of zeros, the number of positive x-intercepts or zeros, I'll just say x-intercepts here, number of positive x-intercepts is equal to the number of sign changes minus uneven amount, uneven number. That even number could be 0, could be 2, could be 4, just anything even. Of course, you want the number of sign changes to be greater than or equal to 0, so that kind of eliminates some possibilities. In the next video, we'll actually show some examples of how we can use this rule, but at least this is the statement. So we'll go to that point. Thanks for watching.